Good day everyone. For today's video, we'll be talking about bijection, injection, and surjection. In mathematics, injections, surjections, and bijections are classes of functions distinguished by the manner in which arguments, input expressions from the domain, and images, output expression from the codomain, are related or mapped to each other. So, what is the difference between injective, surjective, and bijective? For an injective function, the cardinality of the codomain must be greater than or equal to cardinality of the domain. And for a surjective function, the size of the codomain must be less than or equal to the size of the domain. And for a bijective function, the size of the codomain must equal to the size of the domain. Functions can be injections, one-to-one functions, surjections onto functions, or bijections, both one-to-one and onto. Informally, an injection has each output mapped to by at most one input. A surjection includes the entire possible range in the output, and a bijection has both conditions be true. A function maps elements from its domain to elements in its codomain. Given a function f, x is to y. The function is injective or one-to-one if each element of the codomain is mapped to by at most one element of the domain, or equivalently, if distinct elements of the domain map to distinct elements in the codomain. An injective function is also called an injection. As well as the function is surjective or onto if each element of the codomain is mapped to by at least one element of the domain. That is, the image and the codomain of the function are equal. A surjective function is a surjection. The function is bijective or one-to-one and onto, one-to-one correspondence or invertible if each element of the codomain is mapped to by exactly one element of the domain. That is, the function is both injective and surjective. A bijective function is also called a bijection. That is, combining the definitions of injective and surjective. An injective function need not to be surjective. Not all elements of the codomain may be associated with arguments, and a surjective function need not to be injective. Some images may be associated with more than one argument. The four possible combinations of injective and surjective features are illustrated in the adjacent diagrams. It is important to specify the domain and codomain of each function, since by changing this, functions which appear to be the same may have different properties. You can see example below. This is where injective and surjective is to projective. The identity function ID x for every non-empty set x, and thus specifically those exponential function, and also the inverse and the natural logarithm. So for every function f, subset x of the domain and subset y of the codomain, and if f is injective, then x is equals to f to the raised to the power of -1 times to f of x, and if f is surjective, then f of f raised to the power of 1 times y is equals to y. And for every function h is x to y, one can define a surjection. H is x to h of x, and x to h is of x. And then injection, I is h of x to y, and y is to y. It follows that h is equals to I times h. This decomposition is unique up to isomorphism. In the category of sets, injections, surjections, and bijections correspond precisely to monomorphisms, epimorphisms, and isomorphisms, respectively.